Hello everyone, welcome to my channel. In this channel, we will learn how to write programs by using statistical programming languages, such as R and SAS. In the next series of videos, I will present topics on our language. More specifically, these topics will focus on the functions in base R. In this video, I will give you an overview of the R programming language. If there are some specific topics that you would like to learn, please leave a comment. I hope you all enjoy watching this video. If you have not installed R on your computer, you can go to rproject.org to download the R software. RStudio is an integrated development environment for R. In recent years, RStudio is getting more and more popular. It has a better user-friendly interface. To run RStudio, you need to install R first. Then you can install RStudio from rstudio.com. Here is the screenshot of RStudio after you open it. Once you open RStudio, you can type our code into the bottom line of the RStudio console pane, and then click Enter to run it. More specifically, you need to click in the console, and you should see a blinking caret appear next to the greater than sign, referred to as a prompt. This is where you'll type our commands. In this example, we type 3 times 2 plus 4. The code that we type is called commands. After we click the Enter key, RStudio displays a fresh prompt for your next command. You will notice that a 1 appears next to your result. R is just letting you know that this line begins with the first value in your result. Some commands return more than one value, and their results might fill up multiple lines. For example, the command 1:50 generates 50 values. It creates a sequence of integers, from 1 to 50. Notice that new bracketed numbers appear at the start of the second and third lines of output. These numbers just mean that the second line begins with the 15th value in the result, the third line begins with the 29th value, and the fourth line begins with the 43rd value. We can mostly ignore the numbers that appear in brackets. When we type an incomplete command and press Enter, R will display a plus prompt, which means it is waiting for us to type the rest of our command. In this example, we are calculating 1 plus 2. The first plus sign after 1 is the plus operator. After we type the plus operator, we hit the Enter key twice. Then it displays 2 plus prompts, and waits for us to type the rest of the command. After we type 2, and hit the Enter key, the result is returned. The method of typing commands directly into the console is referred to as interactive mode. This method is not recommended when we start writing longer scripts. When we work on a project, it is better to write the commands in a script file. In RStudio, we can select New Script from the File menu to create a script file. The script panel appears in the top left corner. It works like a text editor, where we can type our commands directly. We can also insert non-command texts, such as comments, that serve as descriptions or documentation purposes. The comments need to be placed after the hashtag symbols. After we type commands in the script panel, we can press the Run button. We should see the results of running the script appear in the console panel. The script file should be saved by using .r as the file extension. The R system includes two conceptual parts, the base system and the contributed packages. The base system can be downloaded automatically when we install R for the first time. The base system contains the base package, which is required to run R, and contains the most fundamental functions. The contributed packages that are written by the R users can be downloaded from CRAN. In this example, we installed the tidyverse package by using the install.packages function. Once a package is installed, it is stored on the computer's hard drive. In order to use a function from the package, we need to use the library function. Please keep in mind that we don't need to use the library function for the add-on packages when we install R for the first time. Now let's see what we can do by using the R software. We can use R software as a calculator. Once you type an expression after the prompt, and hit the Enter key, R will return a result to us. In this example, we calculate 3 times 2 plus 4, 4 square plus 1, and log 2 plus the exponential of 5. For illustration purposes, both commands and the results from our console are shown on the slides. When you test these codes, you only need to type the commands. If you also copy the prompt symbol and the results, it will generate an error message. The result from an expression or command can be assigned to a variable by using the assignment operator. The assignment operator is represented by a less than sign, and immediately followed by a dash. We can also use an equal sign for the assignment operator. For example, after we assign 5 times pi to variable A will hold the calculated result. Then we can either type the name of the variable, or use the print function to see the value that A contains. A is a variable, more precisely, A is a type of object, which is a vector. We will discuss more about the vector object later. The most important type of an R object is the vector, which can be constructed by using the C function. For example, both weight and height vectors are created by using the C function. Function arguments need to be separated by commas. Once weight and height vectors are created, we can perform the calculations between these two vectors. Most of the time, we can perform calculations between vectors of the same length. It is also possible to perform calculations of vectors of different lengths. In this case, the shorter vector is recycled. For example, to calculate body mass index or BMI, we can use weight divided by height square. To calculate BMI, the element-wise calculation is conducted. For example, the first element from the weight vector is used with the first element of the height vector. The number in the equation is also a vector, but with a length only equaling 1. Since this vector 2 only has one element, it will be recycled against each element of the longer vector during the calculation. Generally, when vectors of different lengths are used for calculation or comparisons, the lengths of the longer vectors are always multiples of shorter vectors. There might be a situation where the length of the longer vector is not a multiple of the shorter vector. This is generally not intended by programmers. In this situation, a warning message will be issued, like the example on this slide. A is a vector of length equaling 3, while B has a length of 2. Since the length of A is not multiple of the length of B, R generates a warning message. Since B is a shorter vector, it extends its length by recycling its elements. During the calculation, vector B is extended to 1, 2, and 1. To calculate the mean value of a vector, we can add each element by using the sum function, and then divide the summed value by the vector's length. The length of a vector can be found by using the length function. Alternatively, we can use the mean function directly to obtain the mean of the vector. As you can see, there are many ways to achieve the same result. Sometimes, we might not know the function to solve the problem directly, but we can always find an alternative method to achieve the same result. One of the strengths of using the R language is that it has many statistical functions. These functions are from the stats package, and they've already been installed on the computer after you install the software. For example, we can use the t.test function to perform one sample or two sample t-tests. There are other well-known and common use statistical functions, such as the lm function for building a general linear model, or the glm function for building a generalized linear model, etc. Another strength of using our software is that it has many functions to generate graphics. These functions, such as the plot function, are part of the graphics package. There are also recently developed graphics packages, such as ggplot2, which can generate high-quality figures. The documentation of each function can be found by using the help function. To see the documentation of an operator, we need to enclose the operator within tick marks. If we know the name of the function to perform a certain task, but we are not sure about the argument names, we can use the args function to obtain the argument names. Lastly, the help.search function can be used for searching for a specific function to perform a certain task. There is another situation when we only know part of the function name. We can provide the partial name to the apropos function, which will return all the function names that contain the partial provided word. Another advantage of using this function is that we can provide a regular expression for searching. The topic of regular expression will be discussed in a future video. The example function is also very useful when you want to see examples of using a specific function. Everything within the R language is an object. It is very important for beginners to be able to distinguish different types of objects. The basic data objects, such as vector, matrix, array, list, and data frame, can be organized by their dimensionality, or by their capability of storing different data types. For example, vectors, matrices, and arrays can only contain one type of data, such as numeric, character, or logical. On the other hand, lists or data frames can store data with different data types. To distinguish data by their dimension, vectors and lists are both one-dimensional. Matrices and data frames have two dimensions. And lastly, an array can have more than two dimensions. The nature of our objects can be described by their own attributes, and the number of attributes for each object is different. When we manage objects in R, it is critical and important to be able to distinguish different objects by examining their attributes. The storage mode and class are used to describe the characteristics of objects. We can use the typeof function to find out the storage mode of an object. The most encountered storage modes are integer, double, character, and logical. For example, the storage mode of the n1 vector is double. The class attribute describes the data structure of an object. For example, we create a matrix n2 by using the n1 vector via the matrix function. The n-row argument is to specify the number of rows for the requested matrix is 2. The storage mode for n2 is the same as n1, which is double. When we use the class function for n2, it returns the value of matrix and array. That means n2 belongs to two classes, because a matrix is an array, but with only two dimensions. When using the class function for a vector, it doesn't return vector. It returns numeric for a numeric vector, character for a character vector, and logical for a logical vector. To create a list, we can use the list function. In this example, we create a list, named L1, which contains two components. The first component is a numeric vector, and the second one is a character vector. Both typeof and class functions return list when we provide a list object. This example creates a data frame by using the data frame function. We often refer to the vectors in a data frame as variables. In this example, D1 contains two variables, n and l. N is a numeric variable, and l is a character variable. A data frame is a special case of the list object. That is why the typeof function returns list. We will learn more about the characteristics of a data frame in the next video. The functions that start with is dot are used to test whether its argument is of a required mode or class. The returned result is either true or false. For example, is.numeric, is.character, and is.logical are used to test whether its argument is numeric, character, or logical, respectively. There are many is.functions, such as is.vector, is.matrix, and is.array, etc. Once an object is created, we can examine its content by printing the object. However, most our objects are very large, and they are not suitable for printing. Instead of printing the entire object, we can use the str function to display the internal structure of an object compactly. For example, when using the str function to display the D1 data frame, it only lists the first few elements of each variable. The head or tail function are also useful for displaying the first or last few components of an object. The default number of components that are being displayed is 6. Now let's talk about missing values. Missing values are represented with NA. NA is a logical vector of length 1. When we use NA inside the C function to represent missing values, NA will be coerced to the correct data type. For example, when NA is used when creating a numeric vector, NA will be coerced to the numeric type. The missing values are sometimes intended, or may result from computation, or data type conversion. For example, C1 is a character vector. When we use is.numeric function to convert C1 to a numeric vector, it will return a vector of missing values. To examine whether a given vector contains missing values, we can use is.na function. The returned value from the is.na function is a logical vector, with the same length of its argument. A true value in the result indicates the corresponding element is missing. In general, operations on missing values result in missing values. For example, n4 contains a missing value. When we use the sum function to calculate the sum of n4, it returns a missing value. Most functions for calculating the descriptive statistics have a na.rm argument. Setting the na.rm argument to true removes the missing values during calculation. In the last section of this video, we will talk about session management. The working directory is the directory in which we'll look for and save files. We can find out the current working directory by using the getWD function. We can use the dir function to list the contents of a directory. Sometimes the default working directory may not be the ideal choice for us to save files. In this situation, we can use the setWD function to change the working directory. Another concept that is related to our R session is the workspace. The workspace is our current working environment that contains all the objects that we have created. The ls function can be used to list all the objects. For examples, here are the objects that we have created. We can remove or delete one or more objects by using the rm function. This example removes height and weight vectors from the workspace. To save objects to a file, we can use the save.image function. For example, the first command saves all the objects to a file, named lect1.rdata. Instead of saving all the objects, we can also save specific objects by using the save function. For example, the second command saves C1 and N4 objects to a file named foo.rdata. To remove or delete all the objects in the current workspace, we need to set the list argument to ls in the rm function. Once the objects have been saved to an rdata file, we can load these objects into R by using the load function. Loading objects directly into R, instead of recreating the objects, will save us computing time. Now, let's review what we've learned from this video. This video provides an overview of our software. The most important objects are vectors. The element-wise calculation can be performed between vectors of the same or different lengths. In addition to vectors, we also learned about matrices, data frames, and lists. These objects can be categorized by their dimensionality, or by their capability of storing different data types. For example, both vectors and lists are linear, while matrices and data frames have 2 dimensions. Vectors and matrices can only store one data type. On the other hand, lists and data frames can contain mixed data types. In the end, we learned how to save and load objects to or from a working directory. Please like and subscribe to my channel, and click the bell icon to get new video updates.